Today we're going to be working with investigating monomials. So first, let's talk about what a monomial is. You've got a few examples right here. You've got 2 5/3, 2x, 5/3 y squared, 0, so forth and so on. So here, a monomial can include a number, it can include variables, and it can include products of numbers and variables. So let's give another example of ones that are not monomials. So here if we look at 2 plus x, 9 divided by x, x squared minus 8.5, and the square root of x. So here we have examples of ones that are not monomials. They're variables under a radical or a square root symbol. Variables in a denominator, and if I'm adding or subtracting, those are not monomials. So the next few numbers, we're going to actually do some definitions. So copy this down, and let's look at some definitions. Okay, using the monomials above, we're going to identify the examples of the following definitions. So number 2 says a constant is a monomial with no variables. So you should have the examples written above. It'd be 2, 0, negative 8.5, 5/3, and the square root of 5. Those are examples of constants. They're just numbers. Okay, so my next one says in a monomial, the coefficient is the numeric factor of a variable or variables. So here, if I'm looking at some examples, for instance, if I look at the 2 in 2x, that 2 is the coefficient. It's the number in front of the variable. Or the negative 8.5 in front of negative 8.5x y squared. Or how about the 5/3 in 5/3 y squared? Or the last one would be the 9 in 9a squared b to the 3rd c to the 7th. So a coefficient is just the number in front of the variable. Okay, so if I look at number 4, 4 says the degree of a monomial is the sum of the exponents on the variables only. So make sure you underline that where it says it's the sum of the exponents on the variable only. So I'm only talking about the exponents with my letters. So here, if I look at some of my examples. For my monomial, I have 2x. So the degree is going to be 1 because I have a 1 for an exponent, even though it's not written. We assume it's a 1. There's 1x. For the next one, I've got 5/3 y squared. I have it squared, so the degree is 2. Now let's look at the next one. It says negative 8.5 x y squared. Why is that degree 3 and not 2? You should have said because my x has an exponent of 1, even though it's not written. So 1 plus 2 gives me a degree of 3. Let's look at the next examples. Here I have 9a squared b to the 3rd c to the 7th. So when I add my exponents, which is 2, 3, and 7, I get 12. That's my degree. Now look at the square root of 5 and 0. Are there any variables in those two examples? No. So I can't have any degrees. That's why both of those are a degree of 0. Okay, so let's flip the page. Okay, looking at the next page, we're going to talk about some rules for simplifying monomials. So let's look at this first one. It talks about multiplying. So here's my sample equation. I've got 5x squared y to the 3rd times 4x y to the 4th. So if you look on how they expanded it, they took the number 5. Since I had x squared, I know I had 2 x's, so I wrote the 2 x's. I had 3 y's, so I wrote 3 y's. And I did the same thing for 4x y to the 4th. We reordered it to put the numbers in front, then my variables in alphabetical order. Okay, so here, when I actually did that, I'm going to multiply them all together. So 5 times 4, I get 20. How many x's do I have? That's right, I've got 3. And how many y's do I have? Should be 7. So what did we end up doing? It says, what's the shortcut? What did we do to our coefficients, so the numbers in front of the variables? That's right, we multiplied them. And what did I just do with my exponents? You should have said we added them. So my rule for multiplication when it comes to simplifying monomials is I'm going to multiply my coefficients, I'm going to add my exponents. So let's look at the dividing. What do you think is going to happen here? We did the expansion. So when I simplify, what am I going to do with the 18 and 6? That's right, I'm going to divide them. So I get 3. So here, I divide my coefficients. And what do you think I'm going to do? Subtract my exponents. So let's look at them. How many x's do I have? I have 4 on top and 1 in the denominator. Those cancel, and how many do I have left? 3. So I have x to the third. Look at my y's. Those are going to cancel, and I just have one left. Now you can put it y to the first or just write y. So I have 3x cubed y. So again, my shortcut is going to be divide the coefficients and subtract the exponents. So if I look at my two rules, I have a to the m times a to the n. So when I write it, it's a mn. Excuse me, that should be m plus n. Okay, and my next one from the division, I should have a to the m minus n. Now note that the bases have to be the same. Okay, so if they're not, then I can't add them together, meaning it has to be the same variables. So like my x's, I added those together, and my y's, I kept those together. So let's look at the next part of the page. All right, this last thing I want to talk about are going to be a few other rules that you will use in order to answer the sample questions and the practice questions tomorrow in class. So my first rule says I've got a to the negative n is equal to 1 divided by a to the n. So if you notice, if I end up with a negative exponent, I can never have answers with negative exponents. So what I have to do is make them into a fraction. So look at my samples. I got 5 to the negative 2. So again, I can't have answers with negative exponents, but I could rewrite it as 5 squared. 1 divided by 5 squared. Now what's 5 squared? Should have said 25. So my answer here is 1/25. Again, I cannot have negative exponents. So let's look at the next one. If I had a variable, I have x to the negative 4th. So how would I write this one? I should have said 1 over x to the 4th. Now here I didn't have to multiply anything out because I didn't have any coefficients. So I just leave it like that. Okay, let's look at the next one. I got b to the 3rd divided by b to the 9th. Now when we said we were dividing, what were we supposed to do with our exponents? Go back up to the notes and look at it. You should have said subtract. So what happens when I have 3 minus 9, I actually get b to the negative 6. Again, I can't have negative exponents, so how would I rewrite that? 1 over b to the positive 6th. So again, if I have a negative exponent, all I do is move it to the denominator and make my exponent positive. Okay, so let's look at the next rule. The next rule says I got a to the m, and it's in parentheses, to the n power. This is what you're going to hear me a lot say, a power to a power. And essentially what that means when I have an exponent to another exponent is that I'm actually going to multiply my exponents together. So if I look at this example, I have 5 squared to the 3rd power. So again, if I multiply my exponents, I really have 5 to the 6th. Because 2 times 3 gives me 6. So when I plug in the calculator and I get 5 to the 6th power, I can multiply that out. Okay, so what would I get on my next one if I have x to the 4th to the 5th power? You should have said x to the 20th. And then let's look at this last one, b to the negative 2 to the 6th. I end up with b to the negative 12th. Now again, I can't have negative exponents, so how would I change this? I should have 1 over b to the 12th. Okay? So let's look at my third rule. This is a divided by b to the m power. And look at your next rule. It's the same thing, just with division and multiplication. The next one says a times b to the m power. If you notice, if I have an exponent, I can actually distribute it to both the numerator and the denominator when it comes to division. And when it comes to multiplication, I actually can distribute it to both the a and the b. So let's look at some examples. If I have 5 divided by 8, or 5/8 squared, I can rewrite it as 5 squared divided by 8 squared. So I have 25 divided by 64. And again, I could just reduce that fraction. Okay, if it doesn't reduce, then you leave it alone. So let's look at what would happen when I had variables. Here I'd have x to the 7th divided by y to the 7th. Again, that exponent is just being distributed to both the numerator and the denominator. So let's look at this last one. I have b to the 3rd divided by c squared all to the 5th power. So when I redistribute it, I have b to what power? What should I do when I have a power to another power? Add, subtract, multiply, or divide. I should multiply. So here I have b to the 15th divided by c to the 10th. And where I got 10 and 15 from, In the numerator, 3 times 5 gives me 15. And in the denominator, 2 times 5 gives me 10. That's where I got those exponents from. Okay, so let's try using the same rule, but using it with multiplication. So here, I have 5 squared x to the 4th. And let me explain where I got this from. That squared has to be distributed to the coefficient. It also gets distributed to the x squared. Now, when I have a power to another power, we said we're multiplying. So the 2 times 2 is where I got the 4 as my exponent. So when I rewrite it, I got 25 x to the 4th. Okay, let's look at the next example. If I distribute this 6 to both the x and the y, I have x to the 6th, y to the 12th. Again, 2 times 6 is where I got the 12 from. So let's look at this last example. I have 4 to the 3rd times x to the 6th, y to the 12th. Again, my 4 to the 3rd power is going to be 64. And then I've got x to the 6th, y to the 12th. Again, 2 times 3 is where I got the 6 from, and the 4 times 3 is where I got the 12 from. So here's what you're going to do using these rules. The next 2 pages, you have sample problems 1 through 8, and you have practice problems 1 through 10. We will work both the sample and the practice problems in class. I would highly recommend that you try these sample problems. That way we can go over them in class tomorrow. All right, make sure you guys watch this video, and I will see you tomorrow.